This video is going to cover similar triangles. Similar triangles are something that most of us professors like to just wave our hands and assume everybody understands, but apparently for the most part that's not the case. Somebody was supposed to teach you a long time ago about how similar triangles worked, and it was most likely your trig instructor. Yes, way back in God knows when you learned trig. But they were so keen on doing this sine, cosine, tangent stuff that they actually forgot to tell you about similar triangles. So similar triangles is a trig thing. We have effectively two triangles. We have one on the left, one on the right. They're the same triangle. Now, the same triangle means that the angles are all the same, meaning that this angle over here in blue, theta, is the same angle over here in blue, theta, and that this angle up here, we'll call it alpha, is the same angle over here, which is alpha. Technically, it don't even matter that this angle is 90 degrees. We can just call him beta over here in the corner, and this is beta. And as long as your triangle is the exact same triangle as far as angles go, we can relate the same triangle on the left to the same triangle on the right. So what that's going to do for us here in solids, even in statics, even in everything that comes afterward, how similar triangles are going to work is, say, on the one side, we might have distances. Right? We usually like to do with trusses or forces at an angle. So distances, we have like a ratio, maybe a slope, maybe you have like a force and they tell you the angle that this is acting. Yet usually we have 3, 4, and then, you know, our favorite 3, 4, 5 triangles. So usually we have some number here, maybe it's in kips or whatever, and it's at an angle and we need to figure out the components in the x and y direction. So we're going to break that into two separate triangles. We have our distance triangles on the right. We have our force triangle on the left. Truth be told, doesn't freaking matter which one you do. You could swap them. It could be distances on the left, force on the right. It's relevant. I'm going to show you why it's all relevant. So for this one, we're going to have our force on the right. So I'm going to come over here with a brand new color, doing an orange, and let's say that we have 26 kips. Yep, we got 26 kips. So this force, this number over here that we said, this thing over here, this is actually 26 kips. And we want to break it down and we want to find the x and y components. So the x component is going to be force x and the y component is going to be force y. Obviously makes sense. How have you done it so far? Have you gone over here, looked at the right triangle where we have distances, and our distances, we said 3 was horizontal, let's call it in feet, 4 was horizontal, there you go, feet, and then we knew it was 3, 4, 5, so the hypotenuse is 5 feet there. So we have our slope that they gave us, a 3, 4 slope. Maybe they gave you degrees, maybe they actually gave you theta. Who knows? I'm sure at this point, if you're not very familiar with similar triangles, you kind of preferred that they gave you theta. But truth be told, theta is not a pretty number in this case, so we kind of ignore it. Instead, 3, 4, and 5 are some beautiful values that we would like to use. So I'm going to show you how what you've been doing this whole time, trig, is what I'm doing with similar triangles. But it's going to be a lot simpler and with less steps. So for starters, how are we going to find this? Let's say we want to find fx. That's what we want to find. How are you going to do it? How are you going to do it? Well, for starters, you're looking at the same triangle here. We just discovered theta's the same, alpha's the same, beta's the same. Maybe you like cosine, right? Maybe you like cosine. So you start off over here, step number 1. You say that I'm going to relate the cosine of theta, theta's in dark blue here, cosine of theta, just so that we're all clear, this is going to be the triangle on the right. So cosine of theta on the right over here is equal to what? Using in SOHCAHTOA over here, so cosine is the adjacent. The adjacent is 3. So 3 feet over the hypotenuse. The hypotenuse is 5. So it's 3 feet to 5 feet. There we go. Yep, having a great time. So that is theta. And right now, what you're probably doing is taking the inverse cosine of 3 over 5, and you're getting a value. and then you're going to round that value. And then what you're going to do is you're going to come over here to the other side, step number 2, and you're going to say that the cosine of that same angle theta, the one that you literally just spent, a few minutes punching it into your calculator to figure out, that one, but on the left side here, is equal to what? Right? We said same thing. We said it's going to be the adjacent, which is force X, over the hypotenuse, and the hypotenuse is 26 kips. So what you did before this, you were like, I'm going to go find theta so that I can plug it in right here so I can find that answer. So again, when you have the same thing, it's still cosine theta. I'm going to rewrite this equation here. I'm going to say 3 feet over 5 feet is equal to cosine of, you guessed it, theta. But cosine of theta is equal to fx over 26 kips, right? Well, then why, Tommy, why do I need cosine of theta? Like, literally, I'm just going to get rid of that, scooch this homie over. Oh, come on, move with me, bud. Move with me. Nope, doesn't want to scooch. Whatever. I could scoot him over. How I could just rewrite him here. 3 feet over 5 feet. There he is. Now he's in the right spot. Ta-da! This is similar triangles. Similar triangles is saying, how about we skip the middleman? How about we skip cosine theta? How about we skip tangent theta? How about we skip sine theta? How about we just skip the middle step and we just get down to the good stuff? Okay, so how does it work? How does it work? Technically, I'm going to try and give it to you in multiple different ways. And obviously, we can actually finish this off. We can just say what we're going to get from here is that fx is going to be equal to 26 kips times this 3 foot to 5 foot ratio, right? This is the end goal. What your professors usually do is they look at these two triangles and they say, oh, I know what f of x is. F of x here is going to be 3/5 of 26. And you go, how the hell did you know that off the top of your head? And it's because they've done these similar triangles for so long that they knew that that was the final solution. And you're thinking, how did you just get that? Again, it's with sines and cosines, but we're skipping this step. So I'm going to give it to you in words, and we're going to treat these words as though they're units. I'm going to say here that the value that I want a value, right? I want the value, and that's on my left triangle. I'm just going to give it an L. The value I want on the left triangle is equal to the value I know, also here on my left triangle, times a ratio here. So times a ratio, and my ratio is usually a distance for value that I want. For value want, we're just going to try and shorthand this a little bit. And again, that's going to be on the right over a distance for value I know. Again, that's on the right. So let me show you how this effectively, through words, kind of cancels each other out. At the very end, I'm going to be left with values, right? Values are actual true units, right? At the very end of this thing, my distances, which are these feet cancel each other out, and I'm left with kips. So these are, in fact, units. So what's happening here is that I'm going through and I'm saying my distances are canceling. I'm left with values. Okay, that's step 1. However, I can cancel another thing. I can cancel my wants and my knows. So in this way, I'm going to say that want and know are two different words. So you see I have wants here, and I have knows. We'll pick a new color for them. Purple's good. There you go. And there's knows. So just like units, my knows in purple are going to cancel each other out. And I'm going to be left with, as you can see here, value I want. That's what I have on this side, the value I want. So now if you kind of treat the words like units, you can see that I'm canceling the no's, I'm canceling the distances, and all I'm left with is values I want. That's how I did this. So when I'm looking at this picture, I'm going, this is what I want. Well, what do I know? What do I know is this thing. That's a hypotenuse. What I want is horizontal. What I know is hypotenuse. So I'm going to do value, this value, 26 kips, times, again, I want the thing going 3 feet. I know the thing 5 feet. So ultimately, on the very quick, I go f of x is, maybe you do the ratio first. You say, okay, so this is horizontally, this is 3 feet. So I'm going to go, yep, horizontal there. And then what do I know? I know a hypotenuse. So I'm going to go my right triangle, which is 5 feet, then times my 26 kips. No matter how you write it, it's the same thing. It's the same thing going on either way. So again, any form of comparison really works here. You want to find Fy, you're thinking, I'm going to have to do the same thing. You can do sine of theta, or you can do cosine of alpha. Legitimately, however you want to do it, you can do it. So at the very end of the day, any form of this works thanks to trigonometry. And actually, you don't have to do it as just left to right. You don't have to compare left to right. You don't, if you don't want to. I think it's really nice to compare it that way, but technically you can do like over like. Yes, in fact, for what we've been doing X, we'll continue to do that. We could say that I'm going to compare likes to likes, okay, not just lefts to right. I can say f of x, which was comparable to his 3 feet, right? That's the same. Those are both the horizontals. And I'm going to compare that to, what do I know? I know at least a hypotenuse, so I'll compare it to the hypotenuse. Now, because I did the force on the top, I've got to pick from the force side on the top. So here we go, 26 kips on the top, and compare it to a distance. So you can see our units are going to be the same. On this side, we're going to have some kips over feet, and on the other side, we have kips over feet. So our units are the same. So we're just going to take care of that and pretend that we're paying attention here. Oops, that's not 3, that's 5. So there we go. So now we're going to do some cross multiply, and what are you going to be left with? At the very end of the day, you get f of x is equal to, again, 3 feet over 5 feet times 26 kips. Oh my god, it is the exact same yet again. So it doesn't matter if you want to compare left triangle to right triangle. You want to do all of the things on the left on the one side and then set it equal to all of the things on the right. Or if you want to do, maybe we should clean up some of these. Or if you want to do the same thing like horizontal to horizontal, right? You could do horizontal to horizontal. So we're doing horizontal here, horizontal there. And then we're going to compare that to hypotenuse here, hypotenuse there. It doesn't matter, either one, like to like or left to right, either one works. So with what we know now, we'll erase that stuff. With what we know now, let's see if we're feeling pretty confident about Fy. What's Fy? We'll go over here, we're going to ask the question. Fy is equal to what? Fy is equal to what? What do I want? I want this guy. He is vertical, yeah? So vertical is on this side 4. So I'm going to do 4 feet. What do I know? Well, technically I know fx, but let's not do fx. What I know is 26 kips. That compares to this guy. So 4 feet over 5 feet times 26 kips. If you don't want to readily look at that, let's write it out then as similar triangles, right? Let's write it out. We got Fy is to 26 kips as the vertical we said was 4 feet is 2. The 26 is a hypotenuse, so this is hypotenuse. There we go. You can see it. You can see it's the exact same thing. So how do I get this so incredibly quickly? It's because I've done that for so long that for me, it comes second nature. For you, maybe you gotta write it out. Maybe every single time you gotta come over here and draw this out until you eventually see the pattern and you recognize it readily and you go, I can do this. But truly, please stop doing trig. Do yourself the favor. Stop doing trig. Because as you can tell, I did trig. That's what I did. I did trig. I just stopped using sine and cosine and took out the middleman. At the very end of the day, similar triangles are no different from the sine, cosines, and tangents that you love ever so much.